Hello, everyone. We're going to get started in just a couple minutes. I am very excited. I cannot tell you how excited I am. Woo! Hello, everyone. I have to worry less about leaking secrets now. And I don't know what's going on with my videos here. Oh, I've got the wrong camera. It's not window cam, it's bench cam. Hello, bench cam. I'm just looking at how to get that statically. Every time my desktop starts up, they switch numbering for YouTube. Can you now reveal everything? Yeah, I think so. Yes. I have a streaming checklist, and I have don't leak secrets, and I have to worry about that less now. The secrets I knew are public now, so I'm super excited. There's a lot of questions that were queued up, so I guess let's get started. Let me double check that everything is going. YouTube is going, and Restream is going. So we are streaming in multiple places. We're on YouTube. We're on Facebook, Twitch, and X, and LinkedIn. So I'm excited. This is going to be good. So, sorry, I'm just moving my windows around after everything goes. So, hello, my name is Scott. I work on CircuitPython for Adafruit. CircuitPython is a version of Python for microcontrollers, which are tiny computers that are inexpensive and super accessible. They like interact with the world. They're the things that are in the door locks in your car and run your toaster and things like that. Really small computers. They do one thing and they do one thing well. They're not like multitasking desktops or anything. So Python is a programming language that's known for being really super easy to get started with, and CircuitPython brings that to microcontrollers. We do that by showing up as a CircuitPy drive where you edit a code.py file and it just goes. Adafruit is an open source hardware and software company based out in New York City, now in Brooklyn, not Manhattan. They've been moving over the last week or the last month, and we'll talk about the impact on the RP2350 launch as well. But yeah, so if you want to support me, you can support Adafruit by going to adafruit.com and purchasing hardware there. I think they are caught up on shipping, and we definitely had a dip. So folks, if you've been waiting to buy stuff, now's the time. If you're waiting for some RP2350 stuff, you want to wait a little longer because we don't have that in stock quite yet. Okay, so that's the big news of the deep dive, and I figure we'll probably talk about it the whole time. So Raspberry Pi came out with a new microcontroller chip. It's called the RP2350. Their first microcontroller that they've designed in-house was called the RP2040. And it's been a super popular chip for us. The Pico and the picodvi are consistently like the top boards that that CircuitPython is downloaded for. So it just goes to show you how popular it is. They're super aggressive with pricing, and the 2350 is a pretty big upgrade from the 2040. So the 2350, maybe we'll just go to the datasheet and we can talk about highlights, and then I'll get into questions. But yeah, let's do the stuff that most YouTubers cover first, which is reading the datasheet, and then we can get into the questions and the Adafruit impact and a lot too. So let's go to the desktop. Oh, I should say, if you have questions, the chat above me now is the Discord chat in the live broadcast chat channel. And so that's kind of like the best place to chat. And I haven't even said hello. There's lots of people and we're all excited. Hello, Beata. Hello, David. Hello, Hams Labs. Hi, DJ Devin 3. Hi, Skur. Hi, Paul. Actually, maybe that was, yeah, Paul's there. C. Grover, hello. Mark Gambler's here. DCD's here. It's a party. And it's super exciting. So, new chip. The RP2040 has been really awesome. XL is on X. Hello. Rufus is here too. Okay, so I've got the datasheet pulled up here. I'm actually I was doing some work. One small thing that is not like a headline feature, but the reason that I had this page up is they added an additional function column here where you can select UART pins on another pinout setup. So this is the one that RP2040 has, where TX and RX are kind of every 4. But now they have another thing here as well. I'm so excited. So yeah, new chip from the Raspberry Pi folks. So the CPU cores within it, there are still 2 cores. Is that how I'll say it? It's still dual core. 2 cores run at once. And each of those instances of 2 cores can either be a Cortex M33, which is a newer design from ARM. And I think of it as like the next generation Cortex M4. So when you're thinking about where it fits in the Cortex M line, think of it in terms of like SAMD51, NRF52, 840. Those are M4s, and like the M33 is like the newer generation of kind of that class. And then there's also Hazard 3 processors, and so there's a bit you can toggle to either run the Cortex M33, or you can run a Hazard 3, which is an open source. It's an open source RISC-V core, actually by one of the guys that works on hardware for Raspberry Pi. And I can pull that up now. And I think I've pointed it out on deep dives before. So if you're an avid deep dive watcher, I mentioned like wanting a build system for this thing. This is why. This is why I went down the build system rabbit hole for a little while, as I had my hands on, or at least knew about this chip. Okay, so new cores. In CircuitPython land, we're just using the Cortex M33. And the reason for that is that the M33 has a floating point unit. This is very similar to the M0 to M4 transition as well. The M4 doesn't have to have a floating point, but generally when we've used it, it does. So it speeds up all your non-integer math. And I did run actually some performance numbers. I don't know if they made it into a blog post. I did add one to a draft, but this is kind of like, I ran some CircuitPython performance benchmarks, and it was about twice as fast. So the benchmarks were like 1.8 to 2.0 times as fast between the RP2040 and the 2350, which is super cool. Speaking of twice as much, there's twice as much SRAM. So the 2040 has 256 plus 8 K of RAM, and now the 2350 has double that again. So it's doubled the 256 to 512, and then there's an extra 8 still. Those 8 are like the scratch RAMs instead. OTP, I haven't done much with that. Up to 60 megabytes of external QSPI flash and PSRAM. So the PSRAM is a new feature. This is pretty common on the ESP chips, where they have a big kind of bulk RAM that's off the die, and we can do that now in CircuitPython, although I'm sure there's bugs. But I think both the Metro and the Feather will have footprints for that. It may not always be populated, but I know there's some questions about that. We'll get into that in just a bit. They talk about switch mode power supply. In general, they're hoping that this is going to be you know what, let me make this bigger. I can make this bigger, sorry. This is going to be much better for low power. I haven't actually implemented that in CircuitPython yet. I've been waiting and waiting and waiting for them to add an API to the SDK for it, and they actually haven't done that yet. Although they did link me to some examples that they were working on literally like today. So that'll come soon. Low power will come soon. It's not there yet. One thing that the Cortex M33 has is security. So this is called Trust Zone. I haven't done much with that. like our whole goal with CircuitPython is to make it easy to modify the code. So like security is not really a thing if your goal is to allow people to change the code. Peripherals are pretty similar. There's an extra PIO, which gives you 4 more PIO state machines. Oh, Mark, thanks for the link to follow along. That's what I've got here as well. And then there's this new HSTX peripheral. If you saw what we did with the 2040, making a DVI feather, it kind of takes that logic that you had to do between the core and the PIO and just makes a peripheral that does it all for you. So in CircuitPython, it acts just like the older Pico DVI, except it doesn't work. It doesn't work like the old one at all. It doesn't take an extra core. It doesn't take any PIO. It's just this HSTX peripheral, and that's kind of the deep part that I want to go into. Lastly, there's more than one package of it now. So there is a QFN80 that has more pins. Hi, Dishepu. So if you ever felt like the RP2040 didn't have enough pins, it was 30 GPIO. Now the 80 pin package gives you 48 and also 4 more analog inputs. Okay, so let's do questions. I guess I should say I've had access to the RP2350 stuff for a few months now, and I've had hardware from them for that time. Let's see, it's August. When did I get it? I don't remember when I first got it, but I've been, yeah. So I see questions. I'm gonna scroll back up in my Discord because I know folks preloaded questions. So let's start with DCDs. These are from 9/27 this morning. First, how could the secure features help some people address keeping CircuitPython code secret? I assume this is a small population. I think there is a world where you could kind of build everything in and then sign the image. I don't know if it's about keeping it secret so much as making sure that it's the code that you want to run. But it's not really that interesting to me. Security is not a goal of CircuitPython, honestly. So second question from DCD, how would external PSRAM enlarge the space of problems addressed by CircuitPython? So this is definitely in the vein of like how the ESP chips work still. It gives you a lot more room, especially to load code. I think that's the best use of external PSRAM actually, is just loading data that you may not need a lot or often, because external PSRAM is much slower than internal RAM. So I would say just think of this kind of like an ESP, where like an ESP has a lot of memory for you. It's a very similar setup where there's an external RAM chip and there's a internal cache. They both have internal caches. They both have some internal RAM. It's basically like an ESP, except it doesn't have any radios. Hardware floating point and DSP speed up solving other CircuitPython issues. Yes, so there's hardware floating point and DSP, and we basically we're faster. We execute faster simply because the compiler can take advantage of those new instructions. So that is awesome, and I'm sure there's more optimization there that we can do. We just haven't done it yet. Any other Cortex-M33 enhancements? It's just a speed boost to me. I haven't really done anything specific to the core. Okay, does the internal 2 MB flash or 54 variants get CircuitPython support? I don't have my hands on those things. In my experience, the flash dies that are packaged in the package, sorry, they act like external flash. So they're connected internally, just like you would connect it externally, except it's in the same package, so you just place one thing. So although I don't have that hardware yet, I don't imagine it's going to be hard to support it. Now, we're going to have to make a decision about how to partition it, because 2 megabytes is not a lot. We were excited that the Pico has 4. That's going to be much good. That's going to be much better. Yeah. Okay, last question from this round for DCD is, how much of Micropython support does CircuitPython inherit? Micropython and CircuitPython support was done separately at the same time, and a lot of the Micropython support, or at least some of the Micropython support, was actually done by somebody at Raspberry Pi and the Pimoroni folks. So just like in the 2040, we don't share a lot on the port side with them. But we're both kind of built on the SDK, so like there wasn't a lot new, a lot different. And we can go over the pull request if we want to as well. Okay, next up from earlier, DJ Devon 3, are custom builds needed if external PSRAM is added? If the board has a footprint, then you won't need a new build. The PSRAM code right now will basically read from the PSRAM lines and validate that the ID of the chip is expected. If it's garbage, then it just won't initialize PSRAM, and it should work just fine. Adafruit sells the 8 SOIC PSRAM chip on DigiKey. You can buy it from us as well. That's the one that I tested with, and the only one that will probably work, but I fully expect to add support for others. How likely is that the Adafruit will support the 8 megabyte PSRAM build for the Feather, even though it's a physical add-on? It's already in there. My Feather here, and actually I can show it. Hopefully I won't break my demo. But I can actually show it to you. I cut my nails and now I can't open this connector. So let's go into product showcase mode, and I will do the big camera so you can see this. So this is a prototype of the Feather layout. So there's the RP2350, and if you've seen both Lemoore's and I's has a lot of flux around it, it's because it's been hand soldered. But I think the board layout is pretty much the layout that we're going to go with. So you've got 2 JSTs here. One is a debug. So this is like the debug JST that is on the Pico with headers. And then it matches up with the debug probe from Raspberry Pi. And then this other one is the STEMMA QT. This is the PSRAM chip here that I soldered onto it. And then the chip next to it is the flash. And then I think the only other interesting thing here is this connector here. So when we saw that there was an HSTX, I was like, why don't we have it match the pinout of the Raspberry Pi 5? If you look at, let's pull up Raspberry Pi 5. Pi 5, not Pi 6. So if you look at the Pi 5, there's these connectors here. And they call them, is it this connector or this connector? Camera display, camera display. So yeah, so these ones. These are 22-pin ribbon cables, and I was like, why don't we just match that? So that's what this is. This is just for display, not for camera. It's high-speed transmission. It is not input. So you'll be able to do displays out of this port here. And I guess I can show this to you. Lemoore was working on this today, but I have the 22-pin ribbon cable to a breakout on a breadboard to an HDMI plug. Lemoore's working on a board that does all this. But we're a bit behind just because Adafruit's moving, or has been moving. The machine line still isn't moved. So yeah, I'm gonna plug that back in. And will Adafruit eventually sell the RP2350 Feather with the PSRAM soldered on? I assume so, but probably not in the first patch. Okay, I'm going to skip forwards. Just see if there's any. Okay, I'm going to keep going through questions. I'm not really caught up on the chat. DCD, I don't think you were actually asking me, but you said, what do you see as the benefits of RISC-V? I think it's super cool that it's an open core and it's an open ISA. It's not going to be as performant, largely because of floating point. So that's why I haven't, like, CircuitPython doesn't support it currently. Is RISC-V easier for FPGAs? Not really, but the implementation tends to be open. That's why you see it on FPGAs more. Like ARM was very restrictive for a while of getting like ARM cores on FPGAs in Fabric, but I think they've loosened that over time in response to RISC-V. Like you used to have to license it or something. Did you actually read all 1,300 pages of the datasheet? No, I did not. I skimmed it. I read the intro and then went to the parts that were interesting to me. Like, I don't need to read the USB peripheral. Like, it's the same one as the 2040. The UART's the same as the 2040. It's not. I mean, it's good to reference, but I don't need to read it. The Pico double library automatically uses the coprocessor for double precision floating point calculations. I don't think that's set up right now in the CircuitPython build, so that's an area where we could probably get more speed if we needed to as well. Skur is excited to get hands on the chip. Did you really go so frequently in long weekend recently, or were you working on this? I actually took the long weekend off. I've been working on this stuff intermittently for months. But this week I was all like getting my ducks in a row so that I could PR it and get it released. So there's a new release for some initial boards. I worked with Citron and Arturo 182 on getting their boards supported kind of from the get-go. So that's why they're there. Trust zone support for CircuitPython, not really. No, not really. Okay. The ultimate smart building blocks power strip. Will it run HDMI projects better? Yes. Yes, I mean, it helps to have double the RAM. And we'll get into HSTX. Tyeth asked, is the HSTX also suitable for high-speed RX? It is not. It is only transmit. How long have you had the folks before they released it? Months? A few months? I don't quite remember. Go looking back when I was diving into the build system stuff. I think that was right around when I started getting it. Rai says, I'm interested in the dual core plus flash partitions in the context of a robot controller that can be flashed with a user program that runs parallel to the preloaded firmware. Yeah, that's kind of the approach that I wanted to take with coprocessors, is just letting you flash whatever you want on the other side and making it easy to like send things back and forth. DCD says, you've mentioned tracing support before. Have you experimented with that on the RP2350? I've not done tracing. I still think I'm in the camp for tracing that I will use Renode for tracing stuff. I have openocd with the debug thing into the 2350 for some like debugging crashes and things, but I've not done any tracing. Yeah, if you do purchase a 2350, go ahead and pick up the PSRAM. It's what, $1 or $2, I think, too. Mark says, after working on the 2040 for a while, I was surprised how much of the datasheet I read over. Yeah. If using the 2354, which has 2 megs internal flash, does code run faster? I have not used the 54 variants at all, but my assumption would be no. In my experience with chips that have internal flash like this, they're not new dies. They're literally just like the regular 2350 die with a, I guess maybe not stacked, but next to it potentially too, another flash die where they just wire bond them together. So it's literally just like they've been connected up internally. So it's still QSPI, it's still behind a cache. That's my assumption. In fact, we could look at the data sheet and it says flash in package. So let's look. Okay, you can't see it. Memory, external flash. I don't know. Usually what they'll do is they'll like straight up tell you like it's connected to these bins. The controller for the QSPI is different. That might actually be why there's better speed as well. Streaming DMA interface, I want to add support for, but we haven't yet. Boot ROM, power resets, clocks, GPIO. I wonder pin locations. GPIO functions. I mean, my assumption is, yeah, my assumption would be that just on the 54s, they're attached to the QMI, right? They're not going to be. Let's just see. 2 megabytes internal flash. It is a separate silicon die, and the die does not implicitly trust it. Okay, yeah, I'm not sure that they actually have. Oh, here we go. There you go. It even tells you like exactly what chip it is. It's the same RP2350 die, except there's this QSPI thing next to it. And then they connect the pins to the internal flash die and the external pin packages. And you can still do the external QSPI RAM. Okay. Ty says, here's a randomish one for you. I find a lot of instability with flash memory, often self-erasing after corruption. Would FRAM solve that? Although at great cost instead of PSRAM. I think I need more details. I don't feel like I've hit that instability that you're referring to. Toddbot says, I wonder how overclockable the RP2350 is. I haven't pushed it. Tyeth points out the DEFCON badge person got it up to 300 megahertz. MEB says, will Adafruit be selling bare RP2350 chips? That's not really a question for me because I don't make those decisions, but my guess would be that in the long term, yes. Like, I think we sell bare RP2040 chips. I imagine we would do that too, but in the short term, they're hard to come by. We're going to use them for our boards first. All right, and I think I'm caught up on the chat. So what are people thinking? Are there more questions? Or should we talk HSTX? Are we ready for HSTX talk? It depends on when they become more available. HSTX says DCD. Okay, so one of the new things in this chip is called the HSTX, and let's just find it in the datasheet here. It's under peripherals. I haven't gotten the temperature sensor working. HSTX, okay. The high-speed serial transmit streams data from the system clock domain to up to 8 GPIOs at a rate independent of the system clock. It is output only, and this pipeline has some fancy stuff it can do. So it can take PIO outputs and put them into here. And it has an async FIFO and an APB bridge, control registers, blah, blah, blah. So you copy 32 bits at a time. You can do some stuff, which is the exciting bit. And then you shift it out. And you figure out where you want to shift it out. And then it's a DDR output. So this is important. It means that you can do 1 bit per clock cycle. So this is how you get the speed that you need in order to do like 640 by 480 DVI. And they warn that like you need your system clock to be able to keep the DMA happy. You got to make sure that you've got enough data coming in to spit it out. Should I just show you the demo? The bit crossbar is nice, so you can configure any of the outputs to any of the pins. Multiple pins, clock generator. Live demo, okay. Okay, let me plug it in. Hopefully it still works. So what I'm doing is I'm plugging the 22-pin ribbon cable into that connector on the edge. Now I'm going to plug my feather in. And I don't have bad apple, sorry. I don't get why people do that. Okay, so I've swapped my picture for the output here. So if I pull up my console, we're now connected to the Feather RP2350. I was almost to say 2040. There is a little bit of a delay, so that you still have all of the displayio machinery. So the way that this is working is just like picodvi, where we're taking displayio and we're rendering it into a frame buffer, and then the frame buffer gets DMA'd through the HSTX out into out the DVI output, and I can go. Yeah, this is a better screen. Okay, so here is this. I'm capturing this output using the HDMI video capture thing that you can get from the store. So this is kind of like the DVI signal coming out that's getting recaptured here. So let me show you that. It's just like a pretty cheap. It's this one, 20 bucks, HDMI capture. This is what I'm capturing it with. And I actually had to do a little trick. It's not going straight into OBS. It's actually going into a VLC window for some reason that then OBS is snagging. And then before I switch back to it, I want to show you the code that I'm doing, the code.py. So I can show you this. So I have a code.py here that is doing a frame buffer, color depth 16, and I'm going to show you different variants of this in just a second, but I'm not going to come back here to show you how I'm changing it. I'm using on-disk bitmap to show this RGB 720p BMP. And I'll show you what that looks like. And then I'm just doing a while true. And let me show you the BMP. It's 2.6 megabytes. So it's definitely not any reason I had to go to VLC first. I wasn't able to get it working. I wasn't able to get it working going directly to OBS for some reason. So here's the display ruler that I've done. If you pull up the Wikipedia page for color modes, Wikipedia. So this list of monochrome RGB formats has these two pictures, and then they tell you all these different palettes. 2-bit grayscale, 2-bit dithered, 4-bit, 8-bit, 16-bit. So I actually snagged these images. They're public domain, and I put them on the display ruler. So I want to show you. I want to show you all the different modes that we can do just by changing HSTX settings, and that impacts the amount of RAM that your frame buffer takes. So it's cool. You can shrink your frame buffer and then do logic in the HSTX to expand it and inflate it back out. So the HSTX is always producing 24-bit 640 by 480, but you can give it fewer bits to do that. I think that's the setup I want. So right now we're doing 320 by 240 at 16-bit color. I'm going to switch back to the DVI output with me. So that's why we can see here, I do like display ruler. So we can see that it's like 320 by 240 or so. Now, in that file I showed you, the code.py, I'm going to switch to 640 by 480, but I don't have enough RAM to do 16-bit color depth, so I'm going to set it back down to 8. So I'll get 4 times the resolution, but half the color depth. And so now you can see that we're like seeing a lot more pixels. I'm not entirely sure why it's showing like as less white. I think on my display it didn't quite look that way. But yeah, so here you can see the full display ruler with the like added parrot, and is this not at the top? That's fine. So okay, so that's, oh, I reset. The white in the parrot is white. Yeah, I'm not sure why it's doing that. It's a good question. It could be the capture, like the capture is capturing it and then converting it to some other color space sort of thing. Actually, I can look at the VLC. It looks like that color on the VLC window too. Okay, so that is color bit 8. Now, if you're into retro computers, you can now also do color 4-bit mode. So this is 1 bit of red, 1 bit of green, and 1 bit of blue, I think is what this is. So I'm going to hit save, and then it's going to restart, and it's going to be reload. And again, I'm not sure. It might have to do with the TMDS encoding of the HSTX, but it does kind of look dark. And again, I don't feel like it looked like, I also have a display here that I was looking at on. I don't feel like it looks like that with the display. EGA, yeah. So the advantage of doing this is that your frame buffer is smaller, and it's going to restart again. And so the slowness there of loading is all of the display I/O. It's display I/O slurping the 2.4 megabyte bitmap and then dumping it into the frame buffer. And the frame buffer is stored at the color depth that I'm setting in the file. So it's smaller. I don't think I have it, so I don't think you can't do pixel doubling on anything but 16-bit color, if I remember right. Because there's some tricks to play There's some tricks that you can play for how you DMA the memory around. But if you go less than 2, you can do color depth 2, and then you get a grayscale. So this is 2-bit, or yeah, 2-bit grayscale. So this is all the same displayio code. The only thing I'm changing in the code.py is the color depth. And then I can also set it to 1. And now I get, for some reason, it's dark picture. I don't think it's as obvious on the display. It might be part of the capture interaction that's causing that. Or it could be, so that the thing that's taking a single bit and producing a whole TMDS, like a full 24-bit color, is happening in the HSTX, and I'm not sure exactly how it works when you're pushing it like down to the bottom of this. So the way the grayscales work is it takes a bit out of the data that was copied, and then copies it to every color, right? So like if you're doing white, then you set a one red, 1 green, 1 blue. If you're doing black, you do all zeros. So I'm just going to go back the other way now. So color depth 2. Color depth. And there's like brightness controls and stuff that could be impacting this. And then to go from 2 to 4, you get low color mode. And then we'll go 4 to 8. So this is 640 by 480, 8-bit color, which is 232, if I remember right, or RGB 332, I think is what it is. So that's RGB 332. If I do 16-bit, it won't come back. I think I released displays, so yeah, it's not coming back. Basically, it runs out of memory for the frame buffer. So I'm setting it to 320 by 240, and now I'm getting 16-bit color, but the pixels are doubled. So the effective resolution that I'm getting is 320 by 240 instead of 640 by 480. But you get more color. So I'm super keen on this. This is all using HSTX. So you're using varying amounts of RAM, and then just the HSTX peripheral, and obviously memory bus transfers. But you're not using any. Doesn't use any PIO, and it doesn't use the second core. So although I haven't gotten it working, we might be able to run like USB host code on the second core in PIO, and then also be outputting to a display, which I think would be super cool. And maybe we want to look at code on how this is done. Mark says, now I wonder how fast a large GIF will run with the FPUs on that and the RAM to load the larger GIF frames. Do you anticipate a learn guide or blog for the display HSTX? I don't know. Do we have one for picodvi already? Because I literally just used the picodvi option. Toddbot says 4-bit color seems like a great option for info displays, high res but with useful bits of spot color. Yeah, and 8-bit is also high res. It just takes more RAM. It's only when you do 16-bit color that you have to knock down the resolution. Lamore would love to get it working where the frame buffer is on PSRAM, but I'm not sure that's possible. So the HSTX itself is requesting 32 bits at a time, and depending on how many bits you're getting out, how many pixels you're outputting for every 32 bits in, depends on how fast you have to be able to, like be able to load memory into the HSTX, right? So the most strenuous well, let's see, the one that you have, the one that pulls the most memory is, if it's 8-bit color, it's doing every 4. And if it's doing 16-bit color, it's also doing every 4. So there's a trick I'm playing. Let me just show you the code. Let me show you the tricks I'm playing, because I was pretty happy with myself. They gave us some sample code, and I got like I think the first example they did was was the 8-bit color to 640 by 480. But once I figured out how to configure things, I figured I could do all of these other variations on it, because it's a pretty cool peripheral. So let's just, I'm gonna switch back to there. HansLab says, is 8-bit done with a color palette? And if so, what is the gamut of the result of the lookup? 8-bit is not done with a color palette. 8-bit is RGB 332, I think. So it just takes the top 3 bits and the top 3 bits and the top 2 bits, I think is how it's happening. There's definitely, like, if we can come up with better ways of doing that, we should definitely think about it. But I'm not exactly sure how. Well, let's talk about how this is implemented, because there is a piece of the puzzle that I don't know how it works. I don't know how it goes from 1 bit of color to a full 8-bit. So, like, in DVI land, you have 3 lanes of data that are going for red, green, and blue. And so, like, a pixel is always 8 bits of those 3 colors. So if I say, here's 1 bit for red, 1 or 0, I don't know how it expands that out at all. I don't know what the logic is there. So common how. So now in Pico DVI, now you see there's 2 implementations. There's a RP2040 implementation, which is the PIO CPU thing, and then there's a 2350 implementation that uses HSTX. And it's been a little while since I worked on this. So you have to do front porch, back porch stuff. So there's actually like commands that you send. It's 32 bits most of the time. It's 32 bits of like pixel data most of the time, but there's also commands that you include in there. Running 800 by 480 on a Feather with a 7-inch display, but I ran into the same issues. It really is, when I'm doing display stuff or even audio stuff, it's really just it's like a bandwidth in the sense of like how many bits can you get from one place to another, how quickly. Like computers definitely feel that way. So there's some standard stuff for like how to do vsync off and on and stuff. This came from their sample code, which is probably public now, just in their Pico examples, I think is where it was, or Pico examples or Pico extras. I don't need these debug things. I don't know if I'm actually using that. So there's definitely DMA, and then we're encoding limits on width and height. Pixel doubled, doing some pin stuff. Making sure that we all allocated it. Width, height, pitch. Align each row to words. So we're doing a port malloc here, and then we fail if it's in PSRAM. Because I'm not sure we can get the data off the PSRAM fast enough to spit it back out to the HSTX. Nor do I think that if we were able to read it that fast, I don't know if we'd be able to write it to actually change it at all. I'm sure people are going to push this chip, and it's going to be fun to see what people do. 2 DMA channels, words per line. We do, so one trick for the pixel doubled 16-bit, we actually do 16-bit DMA transfers because the RP2350, they're explicit. If you do a transfer, Farrah says, test deep sleep current consumption. I have not yet. I have not yet because the SDK hasn't had support for it. But if you want to see what the deep sleep could theoretically be, they do have numbers in the datasheet. I know people are excited for deep sleep, but they just haven't, they ran out of time to do that. So if you look at electrical characteristics, power consumption, this is where you can have some idea what the number is. Power consumption in low power states. These are very like, there's kind of two weird places that they talk about this. These P1s through sub 1s is like really obfuscated. But the main thing is the number of SRAM banks that are active. There's another place in the datasheet I can talk about it, but this 1 and 2 and this 5 and 6 are with one bank of SRAM active, and then the 3 and the 7, which are kind of the lowest, are when there's no SRAM active, but there's no SRAM active, but the X in place cache is still active. I'm not sure. And then the totals in microwatts, which I don't know how to like reverse engineer back to microamps, which is what I'm used to seeing. So maybe we'll do, maybe we'll have some numbers for deep sleep next week. They pointed me to some kind of hacky example code, but I think it's high on their list to do. And so we'll add it once they do that. So sorry, I've been waiting for them to implement it in the SDK, and they just ran out of time. But we'll add it when they have access, or when they add it to the SDK, we'll add it there. I think the other interesting location for that is to look in power. Power states. Yeah, this is the thing that explains what each power state is. So normal operation, low power, so the CPU is off, and then it's the execute in place cache is always on, and then that's P0, and then P1. All right, so the last 4 are with the XIP off as well. So the one that I was hoping to target is this low power XIP off state, but it's tricky. Oh, I was not XIP off, but the SRAM's off. We have this notion of deep sleep in CircuitPython where we have sleep memory that still stays alive. And I think we'd have to leave SRAM on to make that easy to do. So, is it a drop-in compatible with Pico headers? Yes, I think you could. I think you can plop a Pico 2 where a Pico 1 was, and it should just work. I think that's the case. I don't have any of the final Picos though. I got one really early on with the first version of the chip, but I haven't actually gotten a Pico with the current version. So yeah, sorry, I don't have deep sleep numbers. I was waiting and waiting and waiting for them to add that to the the SDK, and they're working on it still. But there's some numbers in the data sheet that, I mean, it'll be better than the 2040, like that's obvious. How much better? I don't know. Okay, so going back to the tricks to do pixel doubling, is if it is pixel doubled, the DMA only does 16 bits. But one thing they say with the memory bus of the 2040 does this too. If you read 16 but want to write 32, it mirrors the 16 in both places, which is cool because that means that we kind of get pixel doubling for free from the memory bus architecture, at least in the row dimension. And then to get the second row again, I think there's some code here that, yeah. Let's see what my comment says. Write control and write address once when not pixel doubling because they don't need to change. I don't remember how that works. Basically, we need to do it twice. So we basically just DMA the row a second time to get the vertical doubling. And then there's this other configuration here. So this configures the mapping of bits from a shift register into the TMDS encoder or expander. So this is how you get. So you DMA'd 32 bits. There could be any number of pixels in there. So you configure it on how you want each lane or like color to pick bits out of that value. So you can see they're like kind of all the same here. 4-bit is RGB and D for dummy. But then grayscale, what we see is that we have the same rotation for all of it. And the number of bits is always the same. So it's taking the same bit and expanding it for red, green, and blue. And then we can, after it does a pixel, it can rotate that buffer of 32 bits. The shift encoder, the number of shifts. So that's the number of shifts kind of between DMA fetches of new data, which is pretty neat. I haven't done this in a while. Some of these comments are not from me. I don't need this either. That was debug pin toggling. So that is kind of my pitch for HSTX and the 2350. I've dove so deep that I've lost some folks. Are there other topics people would like to see? There you can see the memory allocation failure for doing the bigger buffer. Taya says, just curious, apart from displays, any other fancies for the new HSTX? Not really. Toddbot says, so no more devoting core 1 to DVI. Correct. It takes, on the 2350, it doesn't take the other core, and it doesn't take any PIO. Which is making me think I should get USB host working. which would take the other core and and some PIO. Because then we could do DVI and USB host input, which would be pretty neat for a self-contained computer world. Yeah, it's neat. I don't know what they're reasoning for doing that, but it's pretty wild. Yeah, I don't even remember when I did that code, HSTX. It was like, I got the chip, we got excited, I got it running, but then kind of like knew that they were still changing a lot, and so like kind of went off and did some stuff, and then came back and did HSTX because Lamornouchi wanted to do HSTX breakout, so we needed to be able to test it. So I added support for it, and then once I kind of understood the shift encoder thing, I added all the different bit depths. Which the reason you would do like the black and white bit depth is it just uses less memory. In fact, what I could do here is I could, maybe not, because I think I have PSRAM set up, so GC mem free. Yeah, so I've got 8 megs of memory free. I'm just getting lucky that it's able to do the allocation internal RAM, which I think we do have a signal for like I need to be able to DMA it. It's like it will take more code to be able to DMA from external SRAM, and in fact in the IDF they like pretty regularly will copy data out of PSRAM into a buffer they can DMA from an internal RAM. There are some new PIO instructions, and I haven't really looked at it. So the PIO ASM library and probably the internal PIO will have to evolve a little bit too. I haven't looked at it. Big RP says leveraging HSTX for SPI displays seems like it's going to be a fun idea. Hopefully that peripheral can potentially be usable for things like addressable RGB in scenarios where PIO is limited. Well, I mean, the RP2350 has 4 more PIO state machines. I really like, I mean, that's what, like, PIO is great for RGB. Clever says, one weird thing I've noticed, the TMDS encoder block is SIO, so won't that still need a core to pre-convert the pixel data into TMDS form and buffer it in RAM, then DMA it to HSTX PIO? No, that's separate. That's different. And I think that the SIO TMDS encoder, I think is actually on, I think it might actually be in the RP2040 already. So, no, it's a separate TMDS encoder. HSTX has a separate one. It's not the same one that is in SIO. I feel like the RP2040, at least I believe that's the case. I mean, I think that's the case. I think SIO. Maybe not. Maybe they were doing both at the same time. But I don't think it's the same. Maybe not. Yeah, I guess it's not on the 2040. I don't think it's shared though. I think the reason, if I remember right, I think they said it like if you don't want to use HSTX, that's what it's for. Each core is equipped with a TMDS encode algorithm described in Chapter 3 of DVI specification. Oh, that might, well. In general, HSTX is better. But SIO TMDS encoders are included for use with non-HSTX capable GPIOs. DJ Devon3 says, Grayscale looks like it would be helpful for e-ink. Unsure if this code is meant for e-ink, but that code you already have should be easier to make it work. That's why it worked. Like, displayio does a lot of work to do color conversion. So, like, your code in CircuitPython does 24-bit color, and then whatever your display does, it, like, figures out how to kind of downgrade to that. C. Grover says, is there support for I2S via PIO? Yes. I haven't tested it, but there's no reason it shouldn't work. As far as I know, PIO is like a strict superset of the 2040. So I haven't tested it because I assume that all PIO stuff still works. Like NeoPixel works just fine. The clock rate's slightly different, so maybe we have to adjust for that, but yeah, SIO TMDS is for being able to do it on other pins, is what it says. So no, for HSTX, you're not using it. And the HSTX pins, while they're fixed which ones you have for HSTX, you can swap all of those. I2S with PIO. I2S is audio codec, input and output. That's the way it's already implemented, I think. Right, like if we just go to audio bus, I2S out has this program, has some programs that uses PIO, and the SDK abstracts it away for us. So I assume we don't. I assume it works. I haven't tried it, but as far as I know, PIO is like compatible. I haven't tested it, but I fully expect like there's going to be things that come up when people have hardware in their hands. Like I don't feel like I have great hardware in my hands already. Like this chip is it's like hand assembled, so it's like not necessarily like reliable. And then Citron did send me their board as well. And I don't remember where I put it. It might be in my, it's probably in my backpack still. But I got a board from them too. Deshipu says it works. You mean on the RP2350? I was like, do you have a 2350 yet? I haven't tested it, but I assume it works. And I think I did add support for the third peripheral. Data rates for audio are way lower than display. Yanni says CircuitPython on the RISC-V Hazard 3. I haven't done that. As I've shown, like I really dislike CMake. I really dislike our make files. I really would love to move to a world where that's neither of those things. I've talked about this before. The reason I was thinking about how to do it was for this RISC-V stuff. But in the end, it's not that important to me because I don't think performance is gonna compare at all. It does look like the Micropython folks are supporting the RISC-V Hazard 3 core. So if I'm like waiting to see a comparison on that. I'd be very curious to see the difference. But because the RISC-V core doesn't have floating point, I would assume that they're not close. So it's not that important to me. I'd rather like work on the M33 side. Like if you want RISC-V, like the ESP32C series is also RISC-V cores. They're not open RISC-V cores as far as I know, but it's just not, the CPU itself doesn't actually change the way it works that much. Like in a world where like they want to have it cheaper so they drop the Cortex M33, like that's great, but right now I think the M33 is definitely the better choice, the one that's going to work better. Let's see, is there anything else? I'm just going to pull up the PR and figure out if there's any other things I had to do. The HSTX, I think, was the main thing. Clever says, I had a crazy idea. You could have ARM and RISC-V threads in a single kernel. Soft reset a core to either mode, so you just need to have a limited kernel build for both. Share the state and reset into the right architecture and context switch. Maybe. I don't know what that buys you. There's also 2 cores, so you could run one ARM and one RISC-V. Like, that could be cool, is like we could make the coprocessor interface in CircuitPython, like either one would work. Okay. Pico DVI. Boot stage 2. I actually should delete this because we don't use with the RP2040, you had to have a 256 byte set of code that would initialize the flash. And the boot ROM in the 2350 does that for you, which is a little bit dangerous if you're testing it, because say you mess up one of the wires on your flash, it can start up just fine in dual mode, even though you intended it to be quad mode. So there's actually warnings that I added. Let's see, what did I say? Buffered in, like some of these are just file changes. ADC pin numbering. Like it really wasn't that much. I added the memory map. We had to handle 64-bit pin masking. Like reset registers changed, more pins. And then the Pico DVI stuff we've looked at. Number of PIOs is now 3. I don't know if I've actually tested that. The RTC API changed. They now have this like always on timer thing. USB host, I poked at it, but it doesn't work yet. I had to update it. New linker scripts. New sys platform. More pins. They changed the name of the PIO ASM. One thing it has to do that I figured out is if you have PSRAM, you have to flush the whole cache before you do like your file system writes, which is kind of annoying. And so you have to like save and restore these timing and read format registers because the boot ROM overwrites them, which is not what it should do, which I tried to tell them that, but it still does. And let's see, import, we set up the PSRAM, so we try to do chip select. We try to read the PSRAM ID, and then we can check the value, this known good die value. And if it's not that, we disable the chip select, and then we just return. Otherwise, we set it up, and there's like timing here that may have to change for different PSRAM chips, but I only tried the one that's in the shop. I did add some logic for PSRAM sizes, so a megabyte, and then depending on the IDs, figuring it out, mark it writable, and then do a test write. And if the read back, so this address here skips the cache, so this is writing to the device, reads it back, and if it doesn't match, then set PSRAM size back to 0 so it doesn't get used. Otherwise, we add a second pool of memory to our outer memory allocator. And the IDF folks actually just I found a bug in their TLSF implementation that I've talked about on Deep Dive before. I've convinced them that it's a bug and they need to fix it, so they just merged it in, which is cool. Yeah, that's it. Not that much code, actually. Most of it's boards. So there are a few things that are still work in progress. So deep sleep is one of them. And like I said, I'm really waiting for the SDK to support it. So if you look in the boards, you'll see alarm is turned off, that's deep sleep. RGB matrix is off and USB host are off. Floppy IO is also off. I could fix that. Some of these are like RGB matrix has an external dependency that gets submoduled in, and we'll just have to fix that. I was just thinking like that could be a quick fix actually. So I could try doing that today. I had a crazy idea. Could you have RISC in? Oh yeah, I read that. CircuitPython could be ARM on core 0, but then core 1 could be either, and you could dynamically switch. Yeah. And that's something I wanted to do with the like STEM and G0 project as well, which I actually made a little progress on and I want to get back to. DJ Devin3 says, dedicate 1 core to Arduino and 1 core for CircuitPython. Some things do run faster on precompiled Arduino. Yes. The question is like, how do you get the image from Arduino? Like, how do you get the binary from Arduino? And then how does it interface back with CircuitPython? Yeah, it's kind of amazing to me actually looking through this PR being like the PSRAM or the HSTX thing was the biggest change, besides some of the reset registers, but like that's not that much. Really relying on the SDK because they've done a nice job generally with the SDK. Should we see what happens if we turn RGB matrix on? I was also I was working on doing a DEFCON board definition. So is anybody watching at DEFCON and has the badge? Do you want to try my build for me? You mentioned deep sleep, and I noticed that was removed from the datasheet. Do you know anything about these changes? Extended low power sleep states with optional SRAM retention as low as 10. They were removed? I did not know they were removed. I mean, to me, the 10 microamp DVDD thing is just like I don't know how they came up with that number if they don't have example code. Like somebody must have example code, but like, I don't know. And then I'm surprised by the GPIO thing. I don't know why they were removed. I don't know. I haven't noticed that. Is there, are they mentioned in the changelog? Like, they do a good job at release history. Yeah, let's see. Explain how to get Micropython REPL on UART. Oh wait, this is the 2040, sorry. Did they not have it here? That's not a question. Yeah, I don't know. Yeah, they don't have it. Do you want to try my build out? I assume that they have like this internal build system that does it. So yeah, I don't know. That's a question for them. Can't wait to play CircuitPython on RP2350 boards. Yeah, I can't either. If you want to do board definitions, please do. I was holding myself back from buying all of them. I didn't see much related to PIO version and in the PIO ASM some syntax errors with respect to pin counts. We really haven't. I haven't done anything to support the new version of PIO ASM. So that's to do as well. Deshipu says, is the true random number generator used? I kind of assume we get it for free, but I'm not sure. So in here, OS seed random bits. OS use random, get random bits. I'm not sure where we got this. I think the answer is no. We're doing something else on the RP2040 and I haven't switched it. So feel free to file an issue. Oh, and it looks like we might return RP2040 and OSU name info. We should probably fix that too. There's bugs. Yeah, there is a new label. There is a new issue label now for 2350 stuff. It's weird not worrying about what shows in my autocomplete. Because I definitely had 2350 stuff show up in my autocomplete. So this is what I've got so far. USB host, RGB matrix, low power. And there's a board somebody was like, hey, can you support this? And I was like, what's the USB PID? And do you have one already? Like, if I make a def, can you test it? Yeah, I don't know, Clever. You should ask them. I have not done deep sleep testing myself, so. I was hoping to get to it next week. I think they're hearing loud and clear that that's something that people will actually want to be able to do, so I think it'll happen soon, for sure. Okay. I just kind of want to see if I could get RGB matrix going. I don't remember why I like, first thing I did is like just compile it, and if it didn't work, I just turned it off. So let's see what happens when I turn it on. Especially because it's dependent on like the protomatter repo. I don't really want to like have so many different dependencies. But hopefully it's simple. Like, USB host would be good too. So I think next week is probably USB host and deep sleep work for me on this. And then whatever comes up because people will start getting hardware. Circuit matter I hope to return to soon after that. Because I made good progress on circuit matter and I do actually kind of want to get it done. I want to keep working on it. There was something else. Oh, the board I'm looking for is the Citron board. The Citron board has a USB-A connector for being a USB host, so I'd like to fix that too. So like deep sleep and USB host next week would be good. You know what? I bet if we look in lib protomatter, it's just got to check for RP2040. Let's look in lib protomatter. It could be super simple. Architecture, RP2040. What if we go like this? Compiling for CircuitPython. Ah, FCPU. Well, let's say def RP2040. Hi, Dinkelberg. Yeah, they did. It's called the RP2350. It's twice as fast and twice as much RAM. And it's got this cool HSTX thing. See, we couldn't define FCPU because we allow you to change it. Yeah, Mark says they have zero time to really look at one. Well, I'll tell you, it's my job, so that's nice. I have that to go for. FCPU, we would change it, so that's actually not a great way to do it. All this stuff is probably, well, let's see. See how close that gets us. Hey, it built. Now I have to see if it works. Darn. That means I gotta get a matrix out. And I wish I had, I don't trust this feather because it's been hand soldered. I guess I could see, but like, I know that like the I2C pins aren't soldered correctly. Like I tried, like I got an iron on there too. Maybe what I'll do is I'll just assume it works. If you watched Deep Dive with me before, I'm like, this Shipu says, I have some CH32 boards lying on my desk for 2 months and looking at me accusingly. Yeah. I think I'll PR this anyway. I don't think it'll hurt anything. And it'll get the ball rolling. Because I would probably use a feather wing. Yeah, SparkFun has the Pro Micro right now. I thought about ordering one, but I'm super lazy. I'm super lazy when it comes to when testing things, especially wiring. Like the fact that I made this breadboard for the breakout to the DVI connector, the HDMI connector, is just like not something I normally do. So I'm like, I want to do RP2350 with the like feather wing, the RGB matrix feather wing, which is really what I should do. But then I'm like, it's probably right. Like I compiled. And this is, I got in, some of the hardest things I had to do with the 2350 is that I had some crash bugs because they switched the SDK to use weak. There's a keyword in C that is called weak, which is, you can say, here's a function, and if nothing comes along that's not marked weak, just use this one. The problem is that if you use the weak one, it doesn't work. It crashes at runtime. It compiles and links, but it doesn't actually work. And so those are some of the toughest bugs I had with the 2350 was like not, brain. Yeah, not linking in the right thing, because we don't just use their build system, which is I think why Micropython's able to do RISC-V. It's like we do weird things with our build system, and Micropython's opted into maintaining both a make and a CMake build. Compile synth.io with the number of channels cranked just to see what it can do. Yeah, I mean, see, that's kind of why I'm like, well, maybe I should, I have these two big things to do, but then like, it's gonna be like, okay, as people find the problems. And actually, you know what? I should make it a bug week next week because there's a number of 9.1x bugs that need to be looked at too. Before I get back to Circuit Matter, it's probably worth getting into bug mode for a little while. Okay, I'm gonna make a PR for this because I don't think it's gonna hurt anything to protomatter. Like, that's all I changed. It's just if RP2350 is defined. Yeah, the Teensy 4 has a Cortex M7. Although the M33 is newer, the corollary for the newer version of chips for the M7 is like the M85, I think. That's what it is. So like this generation of ARM cores will still have a new version of that as well. 4 versions of it. So there's two different size packages. So the reason the Feather will likely come first, and then the Metro, we'll see, because the Metro will have the bigger package on it. It'll have the 80 pin. The Metro, I have a prototype Metro, and it's got the smaller package, but the HSTX pins on the version I have are also on the pin headers, but with the larger 80 pin package, we don't have to do that. So Limor is working on revising the Metro so the HSTX is dedicated. But yeah, USB host is on the docket for next week, because getting USB host and then doing a HDMI with USB host would be really cool. It's something I've wanted to do for ages, and now I'm just like remembering that. Okay, so let's make a PR before. If folks have more questions, I'm happy to take them. I don't know the state of protomatter, actually. CP ID5. Origin master. I was a little sad we'd named something protomatter, because I was thinking protomatter could be a cool name for the matter library, which turned out to be CircuitPython. PIO ASM was just updated. What was going on there? Ah, Tim's been doing awesome audio work. Yeah, we'll revise this for the new one too. Will there be silkscreen for HSTX or just TX? The HSTX stuff will be broken out on the 20-pin connector. I don't know what the silkscreen will look like. That's not really my deal. I don't really. I have influence over it, but I do not have. Okay, so we're a few versions behind. So I'm gonna pull from the origin, and then I'm gonna commit this. And we should update the name too. Nobody has a DEFCON badge, huh? So I'm just pushing it up. Daisy Seed is the best low-end board for audio. It's pretty high-end. They've done a ton of work. Like they're a really good example of what you can do when you really focus on just one thing. But yeah, I think the RP2350 with its M33 is going to be way better for audio than certainly the 2040. It's going to be more similar to an M4, right? Like, more similar to an M4 because it has the floating point. But it's got way more RAM than, I guess it's got double the RAM of the NRF52842. I don't know what the speed on it. So the Daisy Seed has an external SD RAM chip. So it's a 8-bit wide bus that might that is not DDR. So yeah, I think it's important to remember that not all RAM is equivalent. You can't read it. You can't read all RAM at the same speed. But it's crossed my mind, the IMX RTs could also do SDRAM, just like the high-end ST chip that's on there too. Okay, so I pushed it, and I'll do a pull request just because. I don't really follow that. Like, this is pretty straightforward. Buffer all the things. Beata says I have to wait for 1992 to come back around for DEFCON, and that's going to take a very, very long time. Okay. Let's just read the datasheet. I haven't actually like tried to grok the PIO changes, so let's just do that. I like that they put footprint recommendations. I don't think they had that earlier. The one thing I want to do, one thing I would like to do with this new chip with more pins is my Game Boy cart. I'd like to do my Game Boy cart with that. I'm a little worried that they removed the 5-volt tolerant line, because I was going to rely on that for my Game Boy cart. So it's all new. They're figuring stuff out. It'll be interesting to see when people start getting hardware. Please add boards as you add them. I want to have all the boards supported if I can. Brain is. It's Friday, and I came in yesterday and was like, heads down. Heads down on doing the pull request and then the release. I should test RGB matrix. They figured out it's possible and working on it, but it's complicated. I think it's based on STM32 port. Yeah, so the seed Daisy has an STM32H7 on it, I think. And then the code, like CircuitPython, lives on the on a QSPI flash. Okay, so it's still 5-volt tolerant, but only when it's powered. What's your favorite Game Boy game? Dinklebird asks. Ooh. I don't know. The Game Boy thing I've tried to do is not to play old games, but to be able to program them from CircuitPython. So I had this project that I did with a SAMD51 where you would write commands in CircuitPython to do something like play this note or do displayio and show these sprites. And then what it would do is it would dynamically generate instructions for the Game Boy CPU to do what you want. And it just never worked that well with the SAMD51. Like, I could get it started up, I could show like this custom boot screen and everything, but then like it would crash and it would go off in the weeds. So the RP2350 with PIO was definitely like that's what I need to be able to actually pull this off. But I didn't quite have enough pins. I had like a MIDI input and MIDI output as well, so you could like in theory take MIDI commands in and then play sounds off your Game Boy. So yeah, I do want to get back to that, but I'm not sure when we will. Squid JPEG says, whoa. Okay, let's read about PIO, because I haven't actually done the work to support the new PIO thing. I don't think it's a lot. Okay, changes from the RP2040. Yeah, so homebrew for Game Boy. Yeah, bringing Python to Game Boy was the idea. And I made it really far, but I just don't think the SAMD50 one was quite up to the task. I had like there's some custom configuration logic stuff on the SAMD51, and like, yeah, RP2350 is going to be way better for this. Got more RAM. I need to do the layout. You know, I think I even started redoing the layout with RP2040 and was like, I don't have quite enough pins. Like, Game Boy is a 16-bit address bus, 16-bit address bus, and a 8-bit and an 8-bit data bus, plus the control signals, plus I was doing UART in and out, and I was like a pin or two short. So the larger RP2350 will be great for that. Yes, there was an FPGA board that plugged into the Game Boy Advance that I worked with a while ago. Nice way to get into FPGA design because I have buttons in a display. I would like, FPGAs are also something I'd like to get to, but I wanted to prove out the coprocessor point with the like the stemma G0 stuff, which is kind of like higher on my list. Okay, changes from RP2040. There is a debug config info version register that indicates the PIO version to allow PIO feature detection at runtime, which I don't think we actually need to do. And I think you only had 20-ish consecutive I/O pins. Yeah, I don't quite remember what the limiting factor was. You know what, I might, let's see, KiCad, open project. I might actually have it on here. PyGB, no. Maybe. Here's KiCad. It's an old, oh yeah, so here we go. 4 years ago? Has it been that long? Oh my gosh. That's when this file was last edited. That's not it. So let's see. I had MIDI in, MIDI out. I had addresses 0 through 15, clock read, data output enable, Game Boy reset, data 0 through 7. And did I have something missing? Or did I actually manage to do it? Was it exactly what I needed? I think there's a write pin as well. Let's see, here we have, so I had 3 buffers, 3 8-bit buffers. Yeah, like there's a 3-volt write pin that I didn't have. Oh yeah, and then there's another, I had four 8-bit buffers. So what is that? 8, 16, 24, 28. Yeah, maybe I did figure it out. Anyway, I would redo it with the larger 2350, I think. Because then I would have the write pin. Like 3-volt write I don't have. Oh yeah, and then the reset. Data output enable is an output to this buffer. Yeah, so it's like literally like 1 pin away, I think. Anyway, that's something I'd like to do. Something I'd like to get back to. I want to make it on a thicker PCB too, so you don't need a case. That was one of the problems with the SAMD51 version I did, is I was mimicking the PCB that lives in the Game Boy carts, so you had to have the like plastic cart to go around it. Oh yeah, I haven't read the Bus Pirate stuff about it. I hope people poured it to CircuitPython to it. That's part of the reason I wanted to get it in there so quickly. And Citron did already add another of their boards to it. But I can't also buy them all, nor can I spend all the time doing it. And I don't want to have to deal with USB product IDs for all of them. Okay. GPIO base adds support for more than 32 GPIOs per GPIO block. Each PIO block is still limited to 32 GPIOs at a time, but GPIO base selects which 32. So we'll probably have to add that, or we'll have to do it, we could do it automatically. So we'll have to add some checks that that all of the GPIO used by a program are on the same base. Next, PIO mask and previous PIO mask apply some control register operations to state machines and neighboring PIO blocks simultaneously. Part of what this is all, I was just also trying to like weaken at it when people need it, sort of thing. Shift in count masks unneeded in mapped pins to 0. Right. That sounds more helpful. Registers starting from put-get expose each RX FIFO's internal storage registers for random read or write access to the system. The new fjoin RxPut join mode enables random writes from the state machine and random reads from the system for implementing status registers. Enables random reads and random writes from the system for implementing control registers. Setting both put and get enable random read and write access from the state machine, but disables system access. Okay, and GPIO base is a Boolean. It's either 0 through 31 or 32 through 48, yeah. Or 16 through 47. Okay, and then they added new instruction features. Security features. Improved GPIO input-output delay and skew. Reduce DMA request latency by 1 cycle. PIOs are cool. So those new instructions are ones that we would have, like, to add PIO ASM support for. Thanks, TJ Devon3. Have a good weekend, too. locate GPIO 0 to access more than. Only the values 0 and 16 are supported. Okay, yeah. Interesting. Only bit 4 is writable. Yeah, so that's something we could just automatically set. But it's on a PIO basis, so we'll have to worry about that a little bit. I'm getting hungry. Any other questions? Otherwise, I think I'll just wrap up. My brain is fried. Should I show you the DVI output showing that I have a lot of memory on my feather? Extensive changes between the SVD files. They rewrote their generator, so don't necessarily assume that things have changed a lot. The closed captioning on the stream is leaking spoilers. Is it ahead of me? It says I'm getting hungry several seconds before you said it. It's influencing me. Yeah, it's exciting. I'm excited for hardware to be more available. Nobody's at DEFCON, so I can't get that board def to you. But maybe I'll push that. Dual DVI output with the second one being done in PIO. You'll be limited on frame buffer size if they're going to show different things. Well, and the way I implemented it is you swap between implementations. You could change the code so that you could do both, but that's not what I was planning on. So that would take some work. Okay, so protomatter update has been submitted, and that can process and we can do it. See if I can build the DEFCON board. It is entropic. Oh, I'm in the wrong place. I still boot. I build a boot too, but I don't include it. So. Oh yeah. I need to actually give it a USB PID. I'm hopeful that the protomatter RGB matrix stuff will just work. And then I'll do USB host next week, and we'll be on our way. Love the Factory says, is CircuitPython available on the STM32H or U micros? There are some H's that are supported, but I've heard from people that they're not working right now. Adafruit only sells an F405, so it's hard to justify working a lot on the other lines of the STM chips. But if you want to add it, that would be awesome. Bonham says, does the RP2350 have PIO coprocessors? Yes, it has 3 instead of 2. So it's got 12 state machines instead of 8. find the screen share. My anchor cameras are swapped. I just gave it an ID of 0. Oh, and my pins are right. Are wrong. 29, comma. Three PIO blocks. Yep. PIO coprocessor is probably one of the reasons I've seen it used in applications where otherwise FPGAs are used. Yeah, PIO is really clever. PIO is really cool. I think it was probably the first really novel peripheral that I've seen from when I started working on CircuitPython. I was just like, oh, this is like game changing. It was pretty interesting. And their documentation is really good. Common HAL never reset pin. Which CircuitPython target is best for NeoPixels? RP2040, or if it's a lot, the 2350. PIO is great at transmitting for NeoPixels because it can do the expansion as it loads data in, and then memory. So if you have so many pixels that you need the memory of that you need more memory than the 2040, then the 2350 will be better. But like the PIO is really good for NeoPixels. I was actually surprised. I don't think PIO is used for NeoPixels on Micropython because I saw some timing issues or something, and I was like, PIO is great for NeoPixel. Don't bit bang it, just use PIO. Although we don't have a non-blocking API right now, but maybe we could later. Where did I pull T-display? And timing. Yeah, PIO is much better for reliable timing. You don't have to turn off interrupts. All right, let's call it. Thank you all. It's been a pleasure. Got my excitement out, and now I'm like, I need a food boost. If you know somebody who wants to try CircuitPython out on the DEFCON badge, have them message me on Discord. I'll push it and bug somebody I know that's there. They're just probably pretty busy. Yeah. Otherwise, I'll talk to you next week. Next week will be a short deep dive. It will only be an hour because it is CircuitPython Day next week. And I will not be the only one streaming. A lot of other folks will be streaming too. So my deep dive will be condensed to an hour so that other people can stream around me. You want to support me, go to adafruit.com, purchase some stuff there. I think we're caught up on shipping. The machine line is still not moved, so we're slow to get products in that would have been made in the factory in New York. But soon enough, we'll have RP2350 stuff in the shop too. We're hoping soon. Somebody else is going to build that for us in the meantime. If you want to join the Discord server, which is the middle one here, the URL is adafru.it/discord. Check out CircuitPython if you haven't, circuitpython.org. And as always, a thank you to DCD for timecodes. Excited for us all to get more RP2350 boards in our hands and see what we can do with it. So have a great weekend. I'll talk to you next week. I'm around all week. We'll be working on this stuff. And yeah. No cat cam. I'm not co-located with the cats anymore. I'm in office land. I do have, bench cam is not the right one. Overhead cam, which is the window, out the window here. Thank you all. Have a great weekend. Let me know how your 2350 journey goes, and we'll make it better.